Okay, on to example 3. The factored form of our function is x and x plus 2. And then the denominator, there's a GCF of -4. So when we factor that out, we get x minus 2. You should find that there's no wholes, and that's because there are no common factors in the numerator and denominator. Vertical asymptotes, we look to the denominator, so x equals 2. For horizontal asymptotes, in this case, the power in the numerator is larger, so there is going to be none. However, there's going to be an oblique asymptote, so we'll find that in just a minute. X-intercepts are factors in the numerator, so we have 0, 0, and that comes from the root of 0. And then we have -2, 0, that comes from the factor of x plus 2. Then our y-intercept is if we put 0 in for x, we get 0 divided by 8, which is 0. So our y-intercept is 0, 0. Okay, so our vertical asymptote is at x equals 2. We know there's no wholes. We have the x-intercepts of 0 and -2. And that's it, right? We're kind of stuck on this one. I did mention that even though there's no horizontal asymptote, there is an oblique asymptote. So an oblique asymptote is like a slant. So it could be coming down like this or coming over like this. And it helps us to kind of figure out the end behavior of our graphs at least. So the way that you find an oblique asymptote is with division. You're going to divide this x squared plus 2x by -4x plus 8. So if you need a review of that, go back to chapter 5. This is where we did synthetic or long division. In this case, with that -4, we're going to do long division. So -4x plus 8 is our divisor. Our dividend is x squared plus 2x plus 0. And so what we ask ourselves is -4x times what gets us x squared? And that's where we get that it's a -1/4 x. Okay, so essentially I need to multiply by the reciprocal of the coefficient so that I get a coefficient of 1. So -4 times -1/4 is 1, and x times x is x squared. And then I'm going to take -1/4 x times 8 to get -2x. At this point, we subtract, or really distribute that negative and add. So the x squareds cancel. 2x plus 2x is 4x plus 0. Then we say -4x times what gets us 4x? -1. So we get 4x minus 8. Change those signs, and so we get 8 as our remainder. Any remainder, what you do is ignore it. Okay, so in the quotient is going to be the equation for our oblique asymptote. We could care less what the remainder is. It's what's in the numerator, or what you divided is going to tell you what the oblique asymptote is. So our oblique asymptote is y equals -1/4 x minus 1. And so what we want to do is put that in as a dashed line. So there's a y-intercept of -1, then a slope of -1/4, down 1, run 4, down 1, run 4, and go left 4, up 1, left 4, up 1. So that's kind of enough points for me to kind of eyeball this in. Okay, so it's not a horizontal asymptote, but an oblique asymptote, also known as a slant asymptote. We have enough points on the left-hand side to know our graph kind of comes down along this vertical asymptote, passes through our two intercepts, and then would approach this oblique asymptote. We need to figure out what's going on the left-hand side. I could guess that it's going to be somewhere down in this quadrant, but we want to test a point just to make sure. So we want to test a point where x is greater than 2 because we want to be on the right-hand side of that vertical asymptote. So maybe I try 4. And once again, you can substitute that into the original or the factored form. If we do factored form, it's 4, and then 4 plus 2 is 6. In the denominator, we have a negative 4, and then 4 minus 2 is 2. So 24 over negative 8 is negative 3. So we have the point 4 comma negative 3 on our graph. And just to kind of double check, maybe let's try x equals 3. Okay. So that would be 3 times 3 plus 2 is 5 over negative 4. 3 minus 2 is 1. So 15 over negative 4 is negative 3.75. So we have the point 3 comma negative 3.75. So kind of matching up with what we think it would happen. So it's coming along this slant or oblique asymptote, passes through those 2 points we found, and then approaches the vertical asymptote. So this will be our graph for example 3.